N type, P type பார்த்துட்டோமா? Doping. It's mentioned, I think. So carrier concentration in an N-type semiconductor. Hope you have drawn the diagram. So in N-type semiconductor, the general valence band energy is there, and above you have the conduction band energy. So this is similar to the intrinsic semiconductor. Now here by doping the pentavalent atoms, pentavalent impurity add பண்ணும்போது it provides more number of electrons. Okay, so the majority charge carrier in the N-type semiconductor is electrons. So here you see a new energy level is introduced near the conduction band energy. So இங்க பாத்தீங்கன்னா இந்த இடத்துல energy level is introduced, it is mentioned as ED. ED na என்ன? Donor energy level. Okay, so this consists of the electrons. So the dots closed circle, it is mentioned as electrons. So normally this is completely having this electrons. So just above that the Fermi energy level is present for N-type semiconductor. This is mentioned as the Fermi energy level, EF. Okay, and this is the reference Fermi energy level for intrinsic semiconductor. So that is situated in between, exactly in between the valence band and conduction band. ரெண்டுக்கு இடையில கரெக்டாக இருக்கும். That is at 0 Kelvin. நம்ம ஆல்ரெடி பார்த்தோம் இல்லையா? So EF is equal to EV plus EC divided by 2. So அந்த மிடில் வந்துடும் சரியா? For intrinsic. So இது வந்து just reference-க்காக தான். Now here for N-type semiconductor, it is just exactly in between ED and EC. So here what happens means, here this consists of completely the electrons. Now at first what happens means the electrons from this donor energy level move to the conduction band. So the electrons move here. At the same time it creates a hole in the donor energy level. Okay, so we should find the density of electrons in the conduction band and also the density of holes, or it is said to be the density of ionized donors, because it loses an electron. Okay, so it is mentioned as ionized donors. So these two things we have to consider. So already you know the density of electrons in conduction band. I think you have written that. இங்க போகாதா? So that is equal to 2 into 2 pi m e star k b t by h square power 3 by 2 exponential of EF minus EC by KBT. So put this as equation number 1. Okay. Next, the density of ionized donors also should be considered. So these two are responsible for the conduction. Okay, wow. So that's why we are taking this density of electrons and also density of ionized donors. So density of ionized donors. So for this here you can mention it as Ne, and here this is ionized donors, nothing but it's the holes. So NH is equal to the density of donor electrons. So it is mentioned as a whole, it is mentioned as Nd, and we want to find the ionized donors here, ionized donor. Okay, it is nothing but the whole. So it is multiplied by the probability of finding the holes. Okay, what is the probability of finding the electron? Generally, f of e. So 1 minus f of e means finding the holes, right? So here Nd into 1 minus f of Ed. Understood? Okay. So this one we can write it as NH is equal to Nd into 1 minus, what is f of Ed? F of E na 1 by 1 plus e power e minus ef by kt or kbt. So here instead of e we have ed. அப்ப e ங்கிற இடத்துல என்ன பண்ணணும்? ed. Okay. So 1 minus 1 by 1 plus e power ed minus ef by kbt. Nd into this value. Okay. Now listen, this ed is situated below this ef. ef is above. So ed minus ef, it must be a negative value, right? Okay. So this ed minus ef is less than kbt. I think in the previous cases நாம வந்து எடுத்திருந்தோம், ஞாபகம் இருக்கா? ஒரு சில இடத்துல அந்த வேல்யூ வந்து அதிகமா இருக்கும் kbt விட. So exponential value also more. But here this ed minus ef is less than kbt. Ed minus ef is less than kbt. Therefore, e power ed minus ef by kbt is less than 1. Before that, you have to take the LCM here. The next page. Okay. So 1 minus nt into, sorry, NH is equal to nt into 1 minus kilo energy 1 plus e power so 1 minus f of ed, right? So 1 minus this value divided by 1 plus e power ed minus ef by kbt. So here you have to apply that. So denominator value என்ன ஆயிரும்? Just 1. Okay, and this will get cancelled. So the existing term is nd into e power ed minus ef by kbt. So nh is equal to, okay. So put this as equation number 3. என்ன தப்பா? What's wrong there? Ah. So put this as equation number. Okay, let me put it as 2. First n is 1, then nh is equal to 2. Now, you know the density of electrons in the conduction band, that is equal to the density of ionized donor in the donor energy level. Okay. So, Ne is equal to NH. Okay. So, equation 1 is equal to 2. So, 2 into 2 pi m E star kBt by h square power 3 by 2 into exponential of EF minus EC by KT kBt is equal to ND, the exponential of ED minus EF by kBt. So from this you have to find EF, that is the Fermi energy. Okay, let us see how to find that. So take this to the denominator here, or the exponential terms to the left hand side, this to the right. Okay, so exponential of EF minus EC. If you take this to the denominator, again if you take here, it becomes minus, right? So minus ED plus EF by kBt. Is it right? Okay. So now here that is equal to ND divided by 2 into 2 pi ME star kBt by h square power 3 by 2. So we have EF plus EF, right? EF plus EF, that is 2 EF. Right now. Have you done? So exponential of 2 EF minus, take that outside. So EC plus ED by 2K kBt, just kBt. Okay. So that is equal to, again, that ND divided by 2 into 2 pi ME star kBt by h square power 3 by 2. Right? Now you want to find this EF. So take log on both sides. Okay? So exponential cancel log. So taking log on both sides. So you will get 2 EF minus EC plus ED divided by kBt is equal to log ND divided by 2 into 2 pi, the same term, ditto, you have to write. Okay. Now kBt, take this kBt to the right hand side. This inga pohuma. This term also taken to the right hand side. So EC plus ED. So let me skip one step. So here 2EF is equal to this EC plus ED, here it is minus. Before that, we have to multiply here, right? So let me write that first. KBT log ND divided by 2 into 2 pi ME star KBT. And the next thing, this term will go this side. So plus EC plus ED. So I have taken that minus outside, that's why it becomes EC plus ED. So as a whole, you are taking this to the right hand side. So next step, you will get the answer. So just divide it by 2, okay. I finished? Shall I move to the next? Sanjay. So EF is equal to, here you have this value, EC plus ED by 2 plus, anyone say that? KBT, okay, log, okay, so KBT here also divided by 2, right? So KBT by 2 log, by the same term, okay, 2 into 2 pi power 3 by 2. So this gives the value of EF. So put this as equation number 3. All the terms are there? Okay, right. So EF is equal to this value. So the temperature and also the concentration of these things have the impact onto the Fermi energy, right? So if T is equal to 0, that means at T is equal to 0 Kelvin. At T is equal to 0 Kelvin, what happens? As a whole, this becomes 0. Okay, so as a whole, this value becomes 0. So we will get EF is equal to EC plus ED by 2. So put this as equation number 4. What's the meaning? Look at the previous things in the diagram. So we have the Fermi energy exactly in between ED and EC. So that's the meaning, EC plus ED by 2. So it is in the midway of EC and ED, right? Okay. So we got the value up to EF, Fermi energy வரைக்கும் நம்ம கண்டுபிடிச்சிருக்கோம், ரைட்டா? இப்போ put the next subheading as the carrier concentration of N-type semiconductor in terms of ND, in terms of ND. So we are going to find the NE in terms of ND. So NE, you know the value, that is 2 into 2 pi ME star KBT by h square power 3 by 2. Next, you know, exponential of EF minus EC by KBT. Okay, NE அப்படிங்கிறது equation 1ல நம்ம எழுதியிருக்கோம். So, இப்போ பார்த்தீங்கன்னா here you have to write exponential of EF. For EF you have to substitute this equation 3. EF is EC plus ED by 2 plus KBT by 2 log ND divided by 2 into 2 pi ME star KBT by h square power 3 by 2. So this as a whole, this is EF. Okay, EF minus EC divided by KBT. It looks like a big equation, but it is simple. Just because of this EF, it is appears to be bigger. மற்றபடி இது வந்து equation simple தான். So instead of EF, we have substituted this. Okay, so this value minus this by KBT. Now take the LCM here. EC plus ED minus 2EC. Okay, minus 2EC then by KBT. இந்த இடத்துல மட்டும் இது. Okay, so இப்போ என்ன ஆகும் அப்படின்னா NE is equal to 2 into 2 pi ME star KBT by h square power 3 by 2. Then exponential of EC plus ED minus 2EC, okay, by KBT. So EC minus 2EC, what will you get? Minus EC. So it becomes ED minus EC. Do you want me to write one step, full step எழுதணுமா? இல்லைனா இன்னொரு ஸ்டெப் எழுத வேண்டியிருக்கும். இல்லை, straight away I will write ED minus EC by 2KBT. Is it okay? Do you know how it will, you will get that? Or இதில் ஏதாவது எழுதி வச்சுக்கோ இந்த பக்கம். Since EC plus ED minus 2EC by 2KBT. So EC minus EC, 2EC becomes minus EC. So that is equal to ED minus EC by 2KBT. Okay, பக்கத்தில் வேணா எழுதி வச்சு. So I have written this. Then plus this KBT and this KBT will get cancelled. So 1 by 2 log ND divided by this term 2 pi ME star KBT by h square power 3 by 2. So that thing already we have done as LCM, so this term will exist. Now we can split this equation. Exponential of ED minus EC by 2 KBT, then exponential of half log this value. Okay, or okay, so NE is equal to 2 into 2 pi ME star KBT by h square power 3 by 2. So this one you can take that separately, ED minus EC by 2 KBT. Okay, this is a power m plus n form. So the exponential is applicable here also. So if you write that exponential of this one is see half log this value, half log this value. So n log m form. So log m power n. So you can write into exponential of log ND So let me apply this of both to the numerator as well as denominator. So nd power 1 by 2 divided by 2 power 1 by 2. Okay. Then here 2 pi me star kbt by h square 3 by 2 power 1 by 2 3 by 4. So 3 by 4. I got this. So in the half வந்து இங்க எழுதிருக்கோம் சரியா இது as a whole power 1 by 2 னு வரும் log m power n அப்படின்னு சொல்லிட்டு இத so இங்க வந்து வேணா எழுதிக்கோ since n log m is equal to log m power n. So power 1 by 2 is taken both in the numerator and denominator. Now what will you get? This exponential log cancel ஆயிருமா? Okay. So you see this term, this base term and these are both are same. Okay. And here this 2 can be written as root 2 into root 2 or 2 power 1 by 2 into 2 power 1 by 2. So here we have a 2 power 1 by 2 and one of these 2 power 1 by 2 will get cancelled and we have nd power 1 by 2. So I can write ne is equal to 2 nd power 1 by 2. Now you listen here, this is same, base is same, power is different, 3 by 2 and here you have 3 by 4. So a power m divided by a power n form, so a power m minus n. So 3 by 2 minus 3 by 4, what is the value? Take the LCM and tell me. It is again I think 3 by 4. So you will get 2 pi me star kbt by h square power 3 by 4 then exponential of ed minus ec by 2 kbt. Okay. So ed minus ec, ed minus ec, ed is the donor energy level that is situated just below the conduction band energy. Okay. So ed க்கும் ec க்கும் அந்த எனர்ஜி பேர் என்ன அப்படின்னா ionization energy. Okay, if you want to move that electron from the donor energy to the conduction band energy அந்த அளவுக்கு எனர்ஜி வந்து நமக்கு தேவைப்படுது அதுக்கு பேர் அந்த டிஃபரன்ஸுக்கு பேர் என்னது ionization energy சரியா அப்போ ec minus ed னா கரெக்டா இருக்கும் சோ இங்க அப்படியே உல்டாவா இருக்கு ed minus ec ன்னு இருக்கா அப்ப என்ன வரும் so okay so it is a some value it is mentioned as delta e. Okay, now let me write that here delta e is equal to ec minus ed that is the ionization energy. Okay, so if you write this ne is equal to 2 nd power 1 by 2 into 2 pi me star kbt by h square power 3 by 2 exponential of ed minus ec. So minus delta e, right? So minus delta e by 2 kbt. What is the equation number, student? 5. So this is the final equation. என்ன equation number போட்டீங்க 5 தானே So let me summarize this. First we have to take the energy level diagram for n-type semiconductor. Then you have to equate that two, that is two energy the charge carriers that is present in two energy levels, one in the conduction band energy and another in the donor energy. Okay, so ரெண்டு ஈக்குவல் அப்படின்னு எடுத்துக்கிட்டு NE NH அந்த ஈக்குவேஷன் எடுக்கிறோம். அதுலேருந்து in the case of donor energy level we are considering the ionized donors, which means the holes. So அங்கே வந்து நம்ம எடுக்கும்போது NH is equal to ND into 1 minus f of ED ன்னு எடுக்கும். So 1 minus f of e அப்படினாலே it says about the probability of finding the holes. That is a positive charge. Okay. வெறுமனே f of e அப்படினா says about the electron. Okay. Right. So அப்படியே எடுத்துக்கிட்டு அதுல இருந்து ரெண்டையும் ஈக்குவல் பண்ணி finally we got the Fermi energy. அது வரைக்கும் ஒரு ஸ்டெப். Then Fermi energy முடிஞ்சதுக்கு அப்புறம் நெக்ஸ்ட் என்ன அர்த்தம்? The carrier concentration in terms of nd. So அதான் வந்து ஃபைனலா இங்க வரைக்கும். Is it okay? Sorry. 3/4. Just navigation.